Okay, this is the beginning of Lab2A, and these are the logic gates. So you can do the minimum of 1, 2, 3, 4, 5. You can add another gate if you want. This is probably the easiest way to do that, is to click on Properties, and then um, you can say either Replace or you can actually grab another one. So, but let's just make a copy of this guy, and we're going to turn this guy into a OR gate. Okay. So you click on this, and then you right click, and then properties, and then you'll replace this NAND gate with a OR 2. Now again, you don't have to have all of these gates. I think on the table, just use the ones that you can fill in. If you do anything extra, you can do that as well. Okay. The most important thing about this setup is to make sure you got your pin 1 and 2 of the inputs of these gates and the outputs. The outputs will be set up with the LEDs, or if you have any other display that you want to use. Okay, this will work on your trainers and the ones in the our proto boards in the lab as well. Open lab, that is. I'm gonna copy this guy. Put it about right there. Okay, well, we can move this guy over a little bit. Now up here I actually measured current. Now if you took DC, you know that you have to put your meter in series. Okay, and then I'm measuring voltage here. So that's an AND gate. So let's flip that switch, one of the inputs, and run this again. Everything should be 0, right? So set this up. This should be pretty straightforward. But again, make sure you wire up VCC and ground so there's no shorts. Okay. Now we're going to go down to the function generator, which we are going to set up as a clock. And we're going to go up here. I'm going to stop the simulator. I need to get over here. And I want to click up there where that ground symbol is, and I want to go to signal. I want to go to clock voltage. So you'll see something like a square wave and a plus or minus. That's the one you want to grab. And he's here, and you use, typically we'll start off anywhere from 25 to 50 hertz. So we're not going to be going too fast here. Okay, so this is if you want to hook it up to a 4-channel, but you could sequentially do this. I think in the lab we're just going to do maybe 2 or 3. You're going to just view the experiment and write down whatever you see. Again, as you can see, this is going to be our control signal. So let's put this. We can actually remove this. Okay, so we just have one, so you know that when we run this, how do we get this guy? This is an oscilloscope. I'm going to go to simulate, instruments, oscilloscope. Okay, this is a 2-channel. Now if you decide you want to put all of them in there, you could do that and wire it to the 4-channel, which looks like this. Now you don't have to do this now, but sooner or later you will. But those who are in the open lab are going to have to use the function generator, and then one of the static or the digital switches on that board as well. And the folks at home will also be using the onboard a square wave pulse generator and one of the digital. Okay, so let's run this just to see what it looks like. Okay, so what do we have? Move this over here. This waveform is on my other screen. So let's run this, and you can see that this control, when I press into a logical 1, as you know, and let's just stop that to see what it looks like. So the AND gate, when it's ANDed with the 1, it'll produce a 1, a logic 1. So that's high, low, that is your truth table. If I turn this to a 0, and I run the simulation again, then it's gone. So you want to do this with a couple of these gates. You don't have to do them all, okay? Because what you want to prove is just how the control signal, how it behaves in the circuit, okay? And then write that down. There's a table I'll go through in the lab as well. So you're looking at this oscilloscope. Maybe you guys already know this. So I'm coming in at 50 hertz, right? And then I have my scale here at 10 milliseconds per division. So if I stop this for a second, and I think I may have mentioned this in one of the lectures for Lab 2, is the rising edge of this clock to the next rising edge is going to be what we call our frequency, okay? In this case, it's going to be the total time. So this is going to be close, well, it is 20 milliseconds. So if we take 1 over 20 milliseconds, what frequency is that, okay? So that's one thing you want to observe as well. Okay, when I run this again, 0 to 1, that's what you want to see. Now these guys are at, let's see, this is 5 volt per division and 10 milliseconds in the horizontal. Okay, so each of these, this is 10 milliseconds, 10, 20, 30, 40, and so on. And these right here are 5 volt per division. So if I scale this down, it's going to get bigger, right? So it's 2 volts. So you'll see when we open this up, try to make this a little bit bigger. Okay. Oh, and this guy's shrinking over here. And I offset the control signal so I can see it. Otherwise, it'll be overlapping, right? So you can see how I'm moving the Y position offset. Okay. And I'll bring this guy back to 1 volt per division. I want to go to 0. Okay, and make this back to 5. So frequency, horizontal, it's all here. Okay, so that's this is going to be done both in your simulator and your trainer board, or if you do it in the open lab. Okay, now if you have any problems setting this up, please email me, then I'll tell our senior lab tech to give you a hand with this if you never set up a function generator, clock oscillator, whatever you want to call it. Okay, and you also have the provision or the option to do this guy as well, okay? And you can turn this guy on, and you have 1, 2, 3, 4. This is pretty good. You got an external trigger. Yeah, so you have 4 channels, and you have this one as an option external trigger. Okay, so you don't have to worry about this, but in the lab, open lab, we do have one of these. And you might want to play around with it. But for this experiment in this lab, just do 2 to 3 gates and fill the the table in. It's right beneath the on the second iteration of this lab. So we'll go over that. You may want to alter or modify some of these frequency input to see what the impact is as well. So if I change the time base, or the scale, I'll go, and if I squeeze it up, and you want to use this thing too. See this on the right, okay? To move it. Okay, so that's it for that, and I'm going to go over the lab real quick, upload the actual revised one, and you should be able to be good to go. Again, this is going to be probably due, let's see, next Friday. Yeah, this should be done pretty quickly because you'll have a quiz on Sunday on logic gates, and then we'll get into the DC and AC parameters, which was kind of introduced just as a reading exercise, okay? All right.